All right, it's that time again for another math video. But today we're going to be learning about place value into the thousandths. It'll build on what we've learned before in previous chapters. Today's learning goal is I can use my understanding of place value to recognize that in a multi-digit number, a digit in one place represents 10 times as much as it represents in the place to its right, and 1/10 of what it represents in the place to its left. Now you've had this learning goal before. We're just going to build on what we know and take it into decimals. All right, let's take a minute to review. We've seen this place value chart before, and earlier this year we focused on all this. The place value to the left of the decimal point. If you remember, every 3 digits is separated by a comma, and each of those is called a period. So we have the ones period, the thousands period, the millions period, and into the billions period. Today our focus is going to be on those place values to the right of the decimal point. We have the tenths place, the hundredths place, and the thousandths place. Here's a little trick for moving a decimal point within a number. If you're doing 10 times as much, you're moving that decimal point to the right. If you're doing 1/10 of a number, you're moving that decimal point to the left. Here's some examples. We would read this: 4/10 is 10 times as much as 4/100. If you remember back to the chapter where we did this earlier in the year, the is like an equal sign. If we take 4/100 and we're trying to find 10 times as much, so here's our 4/100, we would move the decimal point one place to the right. That's what it says up here. So move that decimal place to the right. Now I have 4/10. That makes our number sentence correct. The second one is 4/1000 is 1/10 of 400. Well, let's see. If we have 400 and we want to find a tenth of that number, we said up here we're going to move the decimal point to the left. So if I move that decimal point one place to the left, I would have 0.004. That's what I have here. So 4/1000 is 1/10 of 400. You see the pencil sign. Go ahead and take a moment to copy down everything that's on this page into the input of your journal for your notes. All right, let's take a minute to look at our chart. Remember I told you if you're finding 10 times as much of a number, you're moving that decimal place one place to the right. If you're finding 1/10 of a number, you're moving that decimal one place to the left. If it were 100 times as much, you would move 2 places to the right. If it were 100th, you would move 2 places to the left, similar to the patterns we saw in the first chapter. So let's go ahead and look at our first decimal. Here we have 2/100. We want to find 10 times as much, so I move our decimal place one space to the right. Now I have 0.2. So 2/10, which is what I have now, is 100 times as much as 2/100. If I look down here at 5/10, I want to find 10 times as much. I move that decimal place one spot to the right. So I would have 5.0, or I could just write 5. 5 is 10 times as much as 5/10. Down here I have 7/100. If I move my decimal one spot to the right, now I have 7/10. 7/10 is 10 times as much as 7/100. Works the same way with our fraction, except we're moving our decimal point to the left. So let me erase what I did earlier. So 2/100 here, when I want to find a tenth of that number, I'm going to move the decimal one place to the left. Now I have decimal 002. Usually you would put a 0 here to show you have 0 in the ones place. Basically it's just a placeholder. It wouldn't be wrong if you didn't put that 0 there, but that's how you'll see it written in your book. Now moving down to 5/10, if I want to find a tenth of that, I move my decimal one place to the left. Now I have 0.05. I'm going to put my 0 to hold the ones place. So 5/100. 5/100 is 1/10 of 5/10. And down here, one spot to the left is decimal 007. Put my 0 to hold the place. That's 7 thousandths. 7 thousandths is 1/10 of 7/100ths. You can see it's a pattern. I'm either moving the decimal to the right or moving the decimal to the left, depending on its place value position. Now watch out. Don't be tricked by the wording. This is the same thing we worked on earlier this year because it can be so tricky. Think of the is as an equal sign. 1/10 is 1/10 of what original number? In other words, what number started out that when you moved the decimal place one spot to the left, you got 1/10? Well, that number would be 1 or 1.0. Because if you took that number and moved the decimal place one spot to the left, you would get 0.1, the 1/10 that we ended up. You can have also 0.10 and it's equivalent because 1/10 is the same as 10/100ths. And you'll see that a little bit more in class. Let's look at the next one. 5/10 is 10 times as much as what original number? In other words, what number did you start with that when you moved the decimal one place to the right for 10 times as much, you got 5/10 as the answer? Well, the answer would be 5/100ths. I could prove that because if I had 5/100ths and I moved my decimal one place to the right, I would get 0.5, which is my 5/10. 4 is 10 times as much as what number? In other words, I have an original number. When I move my decimal one place to the right, I get 4 as my answer. 4/10. I can prove it. If I have 4/10 and I move my decimal one place to the right, that gives me 4, which is what I was going for. Finally, 8/1000ths is 1/10 of what number? What original number did I start with that when I moved my decimal one spot to the left, I got 8/1000ths? Answer, 8/100ths. I could prove it to you once again. If I moved my decimal one spot to the left, I would get those 8/1000ths. So again, watch out. Don't be tricked by the wording. Sometimes you're figuring out the original number and they've already given you the answer. Time to summarize with your LOL, or line of learning. How can you describe the relationship between two decimal place value positions? Answer in complete sentences using math vocabulary in your math journal. Remember, complete sentences using math vocabulary. Go ahead.